I don't particularly like these microphones or use a bell mic, so I'm going to go like this. So, service resistivity in Louisiana, this is, when I was approached to speak about this, they said, hey, you guys have adopted this. Would you like to give a presentation? I said, sure. So, I titled it A Tale of Adopting New Technology is what it really is. So, I'll go through the background, I'll talk about our implementation efforts to date, and then I'm going to conclude with observations. Okay? So, initial research efforts that we worked on with resistivity concluded in 2010, 2011, and indicated cost savings. Now, this is over rapid chloride permeability, ASUC 1202. Okay? That was the gold standard for decades for measuring permeability of concrete. And on one project alone, we saved roughly 10 grand implementing surface resistivity over rapid chloride permeability testing. And projected cost savings, if we moved it to statewide, which Resistivity wanted, there was a big push to extend service life. And so we said, yes, we'll push it to that. In that research project, there was actually 2 projects. We found the device to be friendly and user friendly. You know, I trained, so let's see here. I've been in Louisiana now for nearly 17 years. So back in 2010, 2011, when we did this work, everybody wondered how easy can you train somebody to use this device. There was a concern for our workforce because the predominant majority of our technicians at the time, many of them don't even have high school diplomas. So how is it going to be easy to train? And I said I could train my 6-year-old, and I trained my 6-year-old to do the test, and he was part of our work precision and bias study as one of the participants. And guess what? His results were just like everybody else. They were within the standard margin area. Okay, so it's user friendly and precise. We use it as a teaching tool at LSU. They come and do non-destructive testing. We give them a crash course, teach them. It takes us 5 minutes, and they conduct testing for us. So it correlates with rapid chloride permeability across a wide range of values, ages, and mixtures. And so the recommendation was to adopt this as a pay item, and we recommended 27 kiloohm centimeters for new structures, which would be 1,000 coulombs or less. Very low resistivity values. That's what we recommended. We adopted it from 2012 to 2014, and we continued to conduct long-term testing of our samples because you know very well that age plays a role, right? The longer you cure, the increase in resistance, the more infilling you're going to get of your pore structure. And so what we saw as we continued to do long-term testing, the SR tended to double between 28 and 90 days. So we started having internal discussions within the DOT as to whether or not 27 was the correct value for us to adopt. Interesting, this can go on a very long time depending upon your concrete structure. The highest resistivity I ever measured in my laboratory was a 2.5-year-old concrete mix-design with a water to cement ratio of 0.55, 60% replacement with Class C and Class F ash. At 28 days, it had initial resistivity of 8, and at 2.5 years, it had a resistivity of like 265. So, this age does play a big role. Interestingly enough, our contractors and producers, our ready-mix producers, who had never had to design, except for 1 or 2 producers, concrete to meet a permeability spec, struggled with that 27. They were used to, running all the way up to the 0.45 water cement ratio requirements in Louisiana, or the maximum. The ones that met it real easily were our precasters. Precasters are, they're used to making good quality, low permeability concrete all the time. And so the 2016 specification revisions reduced this to 22 kiloohm centimeters, and we had a great increase in acceptable performance. At 22, our failure rates were roughly around 2% across the state, but we still have failures. pockets of failures around the state, and we couldn't figure out why. And so we started looking at them. We did a root cause analysis, and we showed that specifications were the issue. So, how many of you here are from a state DOT or an owner agency? Okay, we got like one. Okay, so here's what happens in the state DOT. The materials people go write the material specs, right? And then the bridge designers think that they know better, so they go write a different part of the spec. And what happened was, in this case, they classified structural concrete for bridge approach sites. They got steel in it, right? And so they said, we want a low permeable concrete, but on the flip side, they required 4 or 8 hour strength so they can open those bridge approaches immediately for traffic. The two don't correlate real well. And so once we realized that that was the issue, we were able to revise the specifications, and now our failure rate for resistivity samples is less than 0.5% statewide. So we still have failures, specification of the issue. Bridge approaches, this is what we just talked about. In 2024 or 2021, efforts were changed. We removed this SR on all higher early strength applications unless it was a precast application where they were steam curing or match curing their cylinders. And then we reduced from 22 to 18 at 28 days of age. We did some long-term modeling with this and find that we're still getting 60 to 120 years of service life with our cover and our concrete design. And then we added language for mass concrete specification, changing the age of testing from 28 to 56 days of age due to the low or the slow strength of that. So observation: since we've adjusted our specifications in 2021, we have very few isolated failures. And so this is where we talk about quality control from an academic side all the time. And how do we control that? Generally, we control water, we control batch weights. The root cause of the failures now, we're finding that concrete producers are not adjusting for their water properly, i.e. they're assuming a absorption value, and they're not adjusting based off their actual stockpile moisture contents, and or they're just absolutely blowing total load weights. And so we're finding this actually through an e-construction initiative with e-ticketing. And we're finding computer batch tickets are in some cases 80% different than what is actually on the written batch ticket. And so quality control has led to some of these other things. So we did a study from the Louisiana legislature. So producers argued that we made the concrete so expensive the taxpayers were going to go broke. Unfortunately, the taxpayers are going to still go broke, but that's not the DOT's problem. That's the legislature's problem. Okay? And so we did a linear analysis of structural concrete costs 3 years prior and post SR requirements, and the average bid price stayed exactly the same at $1,100 a cubic yard in place. And so the ready-mix producers called me up, and boy, you get a lot of hate mail with that. I mean, I got phone calls going, you little son of a da-da-da-da-da. And I said, well, what's your bid price go up? 15%. I said, well, their bid price didn't go up 15%, but it went up 15%. I said, well, then part 1 says it's against the law for them to off-balance their bid. Talk to the contractors. I had contractors calling, complaining about it, and one legislator called me and said the same thing, and I said, well, they're not following our spec book. Don't off-balance your bid, and we'll see what the true real costs are. Interesting enough, in 2024, we completed another analysis, and the bid prices have slightly went up from inflationary, but they still are well within line. 10 to 20% increase in costs, but contractors, against the specification. Quality control, though, as we implemented this, anything that affects strength by this much will affect permeability requirements, regardless of what you're doing, whether it's core solution chemistry testing, whether it's bowl or surface resistivity, or the old-fashioned 1202, right? And so in order to control this permeability testing, you have to get a tighter control on your variability from batch to batch. So quality control has increased significantly significantly as a result of the DOT adopting the standard test method for us. One of the things is that we've seen the strength values are extremely less variable. Obviously, as the quality control gets tighter and better, your variability is going to go down. And analysis showed that, with proper construction curing, our service life will easily exceed 100 years. We are in the process of updating that. We have done a study. We just recently completed the chloride profile testing of it where we did some chloride profile testing of 128 different mixtures across a wide range of permeabilities, where we measured both surface resistivity and we did chloride profile analysis on that as well. And those results should be forthcoming within the next 3 to 6 months. So we're interested with that. With that, I am done, and I'll turn the floor back over.